Welcome to the 7th and last video covering quadratic theory at higher maths. This video is going to focus on quadratic inequalities and the skills needed to kind of deal with those. So, learning intentions. I want you to understand how and be able to solve quadratic inequalities. So, what is a quadratic inequality? Well, all quadratic inequations can be written in the standard form. They're basically the quadratic terminology, ax squared plus bx plus c, but instead of an equal sign, they have one of the inequation signs. So, in this example here, you have the greater than or equal to 0. Again, the a not equaling 0 is just a wee bit of terminology. For it to be a quadratic inequality, you must have an x squared term. For it to be an equation, it does mean that the less than, greater than, or less than or equal to symbol is just as valid to use for it to be a quadratic inequality. So to solve an equation, these are the steps. Step 1, you need to find the roots of the quadratic as if it was equal to 0. Okay, so it's y equals ax squared plus bx plus c. So you take the ax squared plus bx plus c part and find the roots of it. So you basically initially ignore the inequality sign and make it equal to 0, factorize it and find the roots, which allows you to then draw a quick sketch. You will then use the sketch you've drawn to decide where the function will be greater or less. This depends on the inequality, the inequation symbol you have, than 0. And once you've done that, you will give the solution as either 1 or 2 intervals of x values. Again, this will make more sense once I can show you examples. Some of you may already kind of be able to kind of conceptualize what we're asking you to do. But hopefully in the following examples, this will kind of clarify what each of these steps mean. So let's look at some examples. So example 1, solve the inequations. Part A is x squared plus x minus 2 less than or equal to 0, and part B is x squared plus x minus 2 greater than 0. If you want, feel free to try these yourself if you follow what was said in the previous slide for the 3 steps. If not, we'll go through it now. So part A, as I said, step 1, no matter what the question says, if it's an equation, you need to identify the roots of the quadratic. So you set x squared plus x minus 2 equal to 0, factorize it, and then solve for both solutions for both roots. Once you have both roots, that allows you to draw a sketch. So draw your sketch. Again, as I said before, when we covered sketching quadratics, there's going to be scenarios in higher where some of the information is not necessary. In this example, the turning point is irrelevant because it actually plays no part in what we're trying or being asked to find. So we only need to have the roots and the general shape. So roots are 1, 0 and minus 2, 0. The general shape is a positive x squared, so we have a minimum, so the general shape is that. The shape is very important here. If you get the shape wrong, you will get the solutions to the equation wrong. So it's very important to pay attention to whether you have a max or not. Step 3, you take the equation you have, which is the one drawn there. You use the graph to determine when is the equation x squared plus x minus 2 less than or equal to 0. Well, looking at the diagram, that means when is x squared plus x minus 2 below the x-axis? When is its y value less than 0? That's in essence what it's asking. So from the diagram, it is less than 0 in the green line. It's below the x-axis after minus 2 all the way to positive 1. So for all those x values, the equation will be less than or equal to 0. So we can make a statement, right? And since that is one continuous green line, we only need to make one interval for x. What that one interval means is it's one interval that has numbers either side of it. So when x is greater than or equal to minus 2, but less than or equal to 1, you will have a quadratic which is less than or equal to 0, which matches the statement we've been asked to prove. So as you know, that is one continuous interval, so it's got two terms either side. So that's what I meant by you'll either have one interval or you'll have two separate intervals. That's the example of one, but you have numbers either side because it's a range of values, it's not just one. Part B asked us, when is the graph x squared plus x minus 2 greater than 0? Well, that's basically opposite of what we've been asked above. So wherever it is greater than 0 will be the two red lines marked. And from that, there are two separate intervals. So we are going to have to answer with two separate statements. Again, meeting the criteria what I said, sometimes it'll be one interval, sometimes it'll be two separate. In this one, the red sections, it's any value greater than 0. Well, it'll be greater than 0 less than minus 2 and greater than 0 after 1. So we need to write a statement, we need to write that mathematically. That just means we write x less than minus 2 or x greater than 1. That statement is meaning every x value that fits those two criteria will give the valid answer of an inequation greater than 0. So hopefully that's kind of clarified the steps I've shown you and how you go about it, and hence I had to teach you quadratic sketching for you then to be able to use that skill to solve a quadratic inequation. And there will be scenarios, as we're about to go through, where you'll need to do that. And it could be part of some of the other videos we've covered with quadratics. So nice straightforward one to start. I picked it from the 2013 higher paper 1 question 19. Back then that was a multiple choice, so you would have had options of different answers. I'm obviously going to make it harder because you don't have multiple choice questions in your exam, so try this without the solutions given. So this one, I've kind of been sneaky. The only way I've been sneaky here compared to the previous question is that it's not in standard form. It's not written ax squared plus bx plus c to begin with. So rearrange it into that form. That's critical because it's going to play two things. It's going to make sure you get the correct ABC terms. What was it? So it's going to make sure you factorize correctly, and it's going to make sure you draw the correct sketch when you get to that step. So at this point, it's up to you. You could actually factorize while still writing a quadratic inequation. You won't be marked down for that because that's still a valid process, but you can't solve for the roots unless you make it equal to 0. So even if you factorize early, you still need to write an equal to 0 and find the roots by that method. So you can either do the factorizing and equate it to 0, or you can equate minus 3x squared minus 2x plus 1 equal to 0, factorize and do it that way. It doesn't matter when you do the factorizing. Solving for both solutions, we get x equals a third and x equals minus 1. At the sketching stage, remember, I asked you to rearrange it for the purpose of it's a negative x squared term, so we're dealing with a maximum, which will change the shape and will therefore change the solutions to the question we've been asked. We've been asked, when is this an equation greater than 0? Well, 1 minus 2x minus 3x squared will be greater than 0 when x is greater than minus 1, but less than a third. Now notice the symbols you use in your intervals are important because it's greater than 0 but not equal to. So we can't use minus 1 and 1/3. We have to be greater than minus 1 but less than 1/3. Example 3. Again, I'm going to up the complexity. This is taken from the new higher exemplar paper 2 question 3. So this is a very relevant type of example. So have a go. I've tried to add a bit of complexity to this question, so take care. Well, the key thing in the statement is find the value of p such that the equation x squared plus bracket p plus 1 close bracket x plus 9 equals 0 has no real roots. That find the value of p such that it has no real roots. They're telling us that the discriminant of this quadratic must be less than 0. And that's a great way for them to introduce quadratic inequations via the discriminant. So values of a, make sure anytime it's in standard form, which it is in this example. So a is 1, b is p plus 1, and c is 9. Sub those values in, rearrange, gather any like terms together, and you end up with p squared plus 2p minus 35 is less than 0. So we need to find when is p squared plus 2p minus 35 less than 0 for the discriminant, therefore, to be less than 0. For this to be the case, we need to go through the same steps before. You can factorize before you then equate to 0, but once you do factorize equal to 0, find the roots of this quadratic. B equals minus 7 and P equals 5. Start your sketch. Again, pause. Make sure you know we're dealing. It's the P squared plus 2P minus 35 that we're trying to sketch, not the one above, the X squared plus P plus 1, X plus 9. I'm not trying to draw that. So again, we're dealing with two quadratics within the same question. It's positive P squared, so therefore it's a minimum turning point quadratic. Draw it in, sketch it in, and then analyze. We are looking for when p squared plus 2p minus 35 is less than 0. So that's the area highlighted in 0, highlighted in yellow, not including minus 7 and 5. That, if p squared plus 2p minus 35 is less than 0, it will cause x squared plus p plus 1 bracket x plus 9 to have no real roots. So therefore, the values of p that will need to be, it's one continuous interval, so p will need to be greater than minus 7 but less than 5. When that's the case, you will get a discriminant that's less than 0, which will therefore mean x squared plus p plus 1x plus 9 has no real roots. So again, this is a good question because not only does it involve discriminant, so it's using your discriminant skills, not only does it involve quadratic inequalities, it's combined unknown letters in it as well. So it's kind of combining 3 skills all within one question. So it's testing your skills and knowledge and understanding of quadratics to the limit. Now, I keep making them harder. The following 2 examples are at the harder end of the scale. I would call these level A, B sort of questions, particularly level A, because there's a lot of understanding needs to go into this for you to be able to answer it. So again, only do these if you are fully confident of trying them, and don't be put off if you don't understand them, because they are at the higher end scale of the question. But I'm hoping the vast majority of people that will watch these videos will want to get to that level. So maybe these are ones you leave till further down the line once you're kind of consolidated your understanding. But again, they're worth doing because of the harder end, top level, hardest type of question I think they could ask that covers this topic. So, example 4. Calculate the least positive integer value of k so that the graph of y equals kx squared minus 8x plus k does not cut or touch the x-axis. So it does not. They're telling you it does not, so therefore they're telling us the discriminant in this example for this quadratic must be less than 0. Again, take your values for a, b, and c, sub them in, and simplify the algebra. We get down to minus k squared plus 16 less than 0. It's an inequation. Do not try and solve it at this point. That won't work. What we want to do is always try to factorize. So I'm going to take out minus and then factorize from there. It will make life easier. You don't have to take the minus out. Factorize. I'm now ready to find the roots. So equate the minus bracket k plus 4, close bracket, open bracket k minus 4, close bracket equal to 0. Find the 2 roots, solve them for both. That means we can ignore the negative. So k equals minus 4, k equals 4. Again, this is the point. I always like you writing it in standard form, so that's why I wanted minus k squared plus 16 less than 0 in its correct form, because that allows you to determine that we are looking at a maximum value parabola, because this is important for your solution. So when we draw it in, you must draw a max turning point. At this point, we were asked to calculate the least positive integer value of k so that the graph does not cut. So we're looking for when the discriminant is less than 0, so that's when minus k squared plus 16 is less than 0, and it does so at these 2 points. So b squared minus 4ac is less than 0 when k value is less than minus 4 and greater than 4, because it's 2 separate intervals, so you need to write it as 2 separate intervals. Now, that doesn't quite answer the question, because we've been asked to calculate the least positive integer value. So we need to look at the positive values of k only, so we can ignore the negative ones for the solution, not for the overall working, but for the solution we've been asked. And we're looking for when it's the least positive integer. Well, it's got to be greater than 4, so 4 is not included here. Well, the next positive integer value is therefore 5. So k equaling 5 will be the least positive integer value for k that will ensure the parabola y equals kx squared minus 8x plus k does not cut or touch the x-axis. So it's k equaling 5 will be the least positive integer value we can select in this scenario. So this one I really like because it was a play on really fully understanding what the words were and understanding how that would then relate to the solution that you found for the quadratic equation. One more example. Again, I rank this as one of the hardest ones I've certainly come across. I haven't done every question from every paper going back into the 90s and 80s, but certainly the ones I've seen through my teaching experience, this is up there as one of the hardest. So, have a go. Now, this one's key. Again, triggers, understanding what the question's asking. It says show that the equation, right? So in a show question, that's giving you an idea that you need to do the working to prove something's the case, and you've been asked to show that it has real roots for all integer values of k. Since it's a show, you cannot make the statement that b squared minus 4ac is greater than or equal to 0. We don't know that, but we need to prove that. Okay, so that subtly changes how we go about it. So don't create an equation when it's been asked to show, because you don't know at that point that it's definitely the case. So a equals 1 minus 2k, because we're taking that as our coefficient of the x squared term. B equals minus 5k, and c equals minus 2k. So each one of a, b, c involves the letter k. That in itself proves, complicated kids might approach this and be, panicking slightly at the fact that it's involved in all. All it involves just means the algebra, when you sub it into the discriminant, is a wee bit more complicated. Multiplying out, taking care to, take care of any negatives, multiply every term correctly by the values given. We simplify down to 25k squared plus 8k minus 16k squared, which simplifies further to 9k squared plus 8k. So it does simplify down to quite a straightforward quadratic, but at this point, we don't know it's greater than or equal to. However, a sketch will still help us understand and interpret what needs to go on here. Because we can't solve it because we don't know what we're being asked to prove. So we need to think this through and prove it. In this occasion, a sketch will help. So factorize, find the roots. So we can equate to 0 to find the roots. That's not as solving anything. That is a fact for whenever you're trying to find the roots of a quadratic. So k will either equal 0 or 9k plus 8 will equal 0. Simplifying that, we've got a k equals minus 8 ninths. When we draw a sketch, we're drawing it for the k, 9k squared plus 8k. So it's a positive k squared, so it's a minimum value. This is the sketch we get. We start at minus 8 ninths, and it goes below 0 all the way to 0. Now, the question asked us to show that the equation has real roots for all integer values of k. What hopefully you will spot is that between minus 8 ninths and 0, there are no integers, right? There are no values of x that are at an integer value when it is less than 0. So therefore, all other integer values, 0, 1, 2, 3, 4, 5, 6, 7, 8, minus 1, minus 2, minus 3, minus 4, are all going to give y values for the 9k squared plus 8k that are positive, or what was it, equal to 0. So therefore, they're going to give a discriminant that is either equal to 0 or greater than 0. And that's a scenario where you will always have real roots if your discriminant is equal to or greater than 0. So this one involves a bit of a statement. Since the discriminant is only less than 0 between minus 8 ninths and 0, so the value of k being between minus 8 ninths, greater than minus 8 ninths, but less than 0, there are no integer values inside this interval. Therefore, the equation will always have real roots for all integer values of k, as p squared minus 4ac will be greater than or equal to 0. That concludes all 7 videos for quadratics. It's a very important topic. I can't stress to you how often throughout the higher course quadratic knowledge and skills will play its part. So again, I stressed you, as I did with the straight line, please try and gain a solid understanding of quadratics, because they are going to be a building block for a lot of other work within this course.